Hello, in this video we'll learn about some basic components of electric circuits and the mechanical analogy of electric circuit. So in electric circuit we know some of the basic components and how they are represented. We know very well that a cell or a battery is combination of cells. So this is one cell, the two parallel lines, one the longer one, the other shorter one. The longer one depicts the positive terminal and the shorter one depicts the negative terminal. This is the source of EMF or voltage. Basically EMF and voltage are two different terms, but right now we are not going into that detail. It provides the potential difference or voltage in the circuit. The current moves out from the positive terminal of the battery, and after completing the circuit it enters the negative terminal of the battery. Now one general misconception we have is whenever the current flows in the circuit, the current is consumed because it's doing some work, but in reality it's not so. What happens is whatever current leaves the positive terminal of the battery, we represent current by this symbol I in general, the same amount of current I enters the negative terminal of the battery always. We will understand it through our mechanical analogy also how it happens. Then we are also aware about this symbol. In general it is called resistance. Now resistance in general is any electrical appliance which consumes electrical power or electrical energy and does some work. So in general everything, the bulb, the fan, the refrigerator, the AC, the microwave, all are resistances in general. They consume electrical power. Mind it, just few moments before we said it does not consume current. The current passes through it and it flows through it. It goes through it unconsumed. The current goes unconsumed. So what is being used is the energy or the power of the current. And we have the electrical switch also. So you can represent it by this symbol, or there is another way of representing it. It's like this. So this we call it as open. Open means it is off. Open and off means the same thing. Now when you put a dot here or we connect it, it's closed, right? Closed, or it's on for that matter. So these are some of the basic components, means the minimum components I'll say we need to make a circuit. And now let's see, compare one circuit with its mechanical analogy. Okay, so let's say this is a cell, this is one wire, connecting wire, so this is resistance, and here we have a switch. This is the positive terminal of the battery, the negative terminal of the battery, and the current by our convention moves out from the positive terminal of the battery. It goes through the circuit, it passes through the resistance is R, it goes through it. Oh, R, this key should be closed for the current to flow. Let's say it's closed, it's on, and the current, the same current I enters the negative terminal of the battery, and some work is done. If it's a bulb here, the bulb glows, light and heat is produced. If it's some other instrument, then the work is done. Now let's compare it to some mechanical analogy, how this current flows in a circuit. Let's assume that this is the ground, the zero level or the ground, and we have one building of some height. So this is one building, right? So these are stories, maybe a 10-story or a 100-story building, whatever. There is, let's say, one water tank at the top of a building. This top of a building, it has a water tank. And on the ground, there is a pond. This is the pond. This is the pond in the ground. And whatever water we have, let's say this water through some opening or a hole or a channel, it falls down, it comes down and falls in this pond. And let's say that we have a motor or a pump. What it does, it collects the water from this base and throws it up. So the water goes in this direction from this pump. This is a pump or a motor, right? It lifts the water up. Again the water comes here in the upper tank. From the upper tank the water falls down, right? So when it goes up, it has potential energy. You remember we have done that gravitational potential energy. At the height it has potential energy, and this water is falling down. Now let's say here we have a turbine kind of a thing or a fan kind of a thing. So what's happening is, whenever water falls over these blades, it makes this turbine move, rotate, and through this rotation you can get some work done through it. Now this is in direct correspondence with our circuit here, electrical circuit. Now let's do the comparison. Here, as we said, this current, whatever current leaves the positive terminal, the same enters the negative terminal. Here the current is this water, the flow of water. Now if you observe carefully, the quantity of water remains the same. Under ideal situations or conditions, no water is lost. Let's traverse the path of the water. From here, top, whatever is the quantity of water, that water falls down, hitting the blades of the turbine, making it move, losing its energy, but not the water. The amount, the quantity of water remains the same. The same water enters this pond. From this pond, the pump sucks it and throws it up. The same water goes up and the same water is rotated. So you can compare here the mechanical analogy. The current also goes and it keeps on rotating. Here the positive terminal, this, it makes the water at high potential. So the current comes to high potential here at the positive terminal, and from the lower potential, from the ground, it's sucked up. So pump is creating the potential difference the same way a cell or a battery creates the potential difference. Now this resistance is like this turbine or the fans of the blade. It's consuming electrical energy. So when water falls over here, it consumes its energy, but not the water, and it moves and rotates. So correspondingly, how you make it, the different electrical appliances, they may do different kind of work, and this continues. I hope it has made this comparison very clear. Oh yeah, we have forgotten one tiny thing. It's obvious, this is key or case switch or key. You can have a tap or a valve where key. If it's not open, it's closed here. When I close, I'm saying it's not allowing it. So understand the difference of being closed in electrical circuit and in mechanical circuit. It will not allow the water to flow, so it controls the flow. So this is one comparison or analogy of electric circuits with the mechanical analogy. Thank you very much.